Ter. Everyone, it's time for the second keynote of today. And let me introduce you, Paola Villareal. Paola Villareal is a data scientist and full-stack developer with over 23 years of international experience leading multidisciplinary teams in the private, public, and non-profit sectors. She served as coordinator of repositories, research, and foresight at the National Council for Science and Technology in Mexico, where she helped to coordinate the COVID-19 efforts. For her work in the field of public interest data science, she has been recognized with the MIT Innovators Under 35 LATAM Award, named one of the BBC's 100 Inspiring Women, and received a fellowship at the Berkman Klein Center for Internet and Society at Harvard University. So, bienvenida, Paula.
Muchas gracias. Thank you for having me. And welcome to Mexico, to all of you that are not from here. I would normally like to do this in Spanish, but because this is an international conference, I was asked to do it in English. So I introduced my presentation so it's be understandable. So as Arturo mentioned, my name is Paola Villareal, and from 2018 to 2021, I had the privilege of leading a data science team under the National Council for Science and Technology in Mexico's government. And in this team, we basically were asked to provide a data science muscle for both the federal government, but also articulating with the universities and the research centers. So this was a very, very interesting opportunity, and I'll give you a little bit of context on this. So CONACYT is the National Council for Science and Technology, is the head of the science, technology, and innovation sector in the government of Mexico. And it basically incentivizes scientific research through many means, right? Like, for instance, research projects or stipends or many other like fellowships or any like monetary incentives for the development of science in Mexico. It also coordinates 26 research centers. They cover most of the science branches, and we work with them to basically create impact using their work, right? Like what I saw when I first came to CONACYT was that a lot of very interesting and very sexy science was being performed in all these research centers, but they didn't have much impact on, actual problems, right? Like it was mostly done to publish papers and to collaborate with other researchers. So they didn't have an applied avenue. So that's basically what we wanted to do. Basically, build the bridge between these amazing scientists and the federal government and all these, the ministries in charge of, for instance, security or health or transportation, whatever. Like if we found a project that could be interesting or to be applied in any of these ministries, we will definitely go and build the bridge and manage the stakeholders and everything. So yeah, it was very, very interesting to me. And when we found like a methodology to enable these collaborations, we called it the Ecosistema Nacional Informático, which basically means the National Informatics Ecosystem. It's a very weird name, but it's basically just what I just described, right? Like articulating between data science or data-driven projects performed in the research centers and the federal government. Right? And we have some access. So I'll give you some examples. The first ENI, or Ecosistema Nacional Informático, that we created was about Mexico's disappeared and missing persons, right? So in the first days of government, Mexico's president said that the top priority was finding the missing persons, like the disappeared, right? And as many of you know, Mexico now has more than 100,000 disappeared people, and this is a big, big tragedy in Mexico. And the government recognized that and basically asked us to enable collaboration between scientists that have the technical power and the Comisión Nacional de Búsqueda, which is the, how would say, like the commissioner for searching these disappeared people. So this was very, very fruitful. We created some projects, for instance, we created one project that was very impactful to deal with the dirty war, which is Mexico didn't have a dictatorship, but we had a single party in power for over 70 years. So it was like the perfect dictatorship, right? During the 70s, like starting from the mid-60s to the end of the 70s, Mexico's army basically disappeared activists and students and any type of dissent, right? And they did that, and what's very strange is that they documented everything, right? Everything is in metric tons of paper and boxes, and it's in a warehouse, and it's very, it used to be super confidential, but in this government, it was decided that it should be open at least for researchers, and eventually it was going to be open to the public, right? So the national, la Comisión Nacional de Búsqueda, had access to these documents, but they didn't have the means to make sense of it, right? It's like, yeah, metric tons of paper. So we helped develop at least the roadmap to make sense of these documents by starting for digitalization, but also recognizing the text, finding logos and signatures, recognizing names, and making a repository with ontological search that enabled the searchers to make sense of who was where, right? So for instance, we could know that if a person was disappeared in Culiacán, Sinaloa, and the general quartel, no, like the headquarters for the army was in Culiacán, and it was led by this general. We knew which times they like coincided and made a match, so they could basically connect the case with other cases using this search engine that was created. Then we also, and this was one of the most, one of the hardest experiences of my tenure in CONACYT, which was the search for contemporary missing people or disappeared people, basically the consequence of the war against drugs since 2006. And it's the response, like the war on drugs is responsible for basically more than 90% of the disappeared in Mexico in the last, like, what is it, like 20 years? So here, it was basically, like the help needed was to analyze specific fields, right, where remains were found. And we did that with like LiDAR or any other technology, but also with models to predict like what was the likelihood of finding more remains or very, very gruesome. And it took me basically like to go on the field, to actually go and search with families and with the authorities, with the army, with the National Guard, in very dangerous places. So the team with, like the CONACYT team and the research centers teams, like we will go with the families and with the authorities and actually go and find or look for people in, like on the ground. Then the second one, it was more about national security. We wanted to provide, or to help build capacity on geographical information systems, do some causal analysis on crime, and do fingerprinting for municipalities, right? So they could know like what explained crime or in specific municipalities. And then something very awful happened, which is the tragedy of Tlahuelilpan, which I'm sure most of you don't know, but there's a very big problem in Mexico that the oil ducts are like punctured, so people steal gasoline and then sell it like on the street, right? And to do that, they create a hole in the oil duct and inundate pit, and then they just, with jars, get the gasoline, right? And what happened is that one of these pits took fire, and it killed like 95 people, right? And the videos there were awful. Like you could see basically people burning alive. And so we were asked to do like social profiles and help the federal police like with data processing and stuff like that. So it was a very specific task force, but it also took the Ecosistema Nacional Informático methodology. And then the last one I participated with was the health ENI, which is like, originally it was more about like research on acute lymphoblastic leukemia due to widespread contaminants, but also on rivers and pollution and transgenic corn and stuff like that, right? So it was more like friendly, but then 2019, well, the end of 2019 came, and we knew right away that this was going to be a pandemic. And I was asked to create a new task force for it. So that's the context of why we were doing this. And now the topic of this presentation is the COVID-19 Ecosistema Nacional Informático. So what we did very early in 2020 was a call for proposals. Like we knew that, for instance, the CIMAT, which is the math-oriented research center, had some knowledge on, how do you say that, like epidemiology, like data science for epidemiology, right? Like they had modeled Zika and other chikungunya and other diseases. So they have experience working with epidemiological data. So we basically asked them to be ready and to create projects that could basically be plug and played with the intention of helping the government to make decisions on the pandemic. We received like 50 or so, like very interesting projects, and we didn't say yes or no to anyone. We just asked them like come to our meetings, like a stand-up meeting. We did like every day, and we'll see from there, right? And at the end of like the first month, we only had like 15, 20 very serious projects. But we basically had time to build a lot of relationships. And why did I had to build these relationships? There's two answers, right? Like one is the most obvious, which is that the pandemic was coming and the government needed information and insights, right? But also the second one is because these researchers were doing this amazing work and dedicating most of their time pro bono, right? So the promise I made to them is that I will do whatever I had to do to bring their insights and their projects to the highest of levels, right? So that's why I had to really, really dedicate myself to building relationships with many government entities and to show them, like what we were working on. I remember one day, I think it was the second or third day during, like, for Mexico's confinement. So I was in El Zócalo, right, like, which is the main plaza in Mexico City. And I met like very high officials in Palacio Nacional, which is where the president's offices are. And then I crossed a very empty Zócalo. It was eerie to see. There was no one there. It was like ghost town. And if you go now, it's like, I don't know, 5,000 people right there right now. But it was all for me. And I crossed diagonally to Mexico City's government's offices, right, where I also show them the projections and all the other projects that we were working on. So we created a lot of projects, like I said, and gave tons of insights. I'm going to show you the most prominent ones, because the way I measure prominence is through impact. And I think these projects basically changed or had an impact on millions of lives. Because at the end of the day, the insights we provided, I was able to bring to the president, basically, and to Mexico City's governor, and very high officials from the health ministry, etc. So, yeah. Once we had the relationships built, which was not very easy because there's a lot of politics implied, but also a lot of competition. Many companies were already, like in talks with the government officials to provide them some kind of insights on how the pandemic was going to behave. But because this was from the National Council for Science and Technology, meaning that the top scientists in Mexico were behind this, it was, I'm not going to say easy, but it was, like not as complicated to reach these ears and these politicians that really needed this data. So after we built that, we started implementing, in production, all these projects. And we wanted to ask these, I would say, 3 main questions. Basically, one of them, the first one is how many ICU units will the government need by municipality in Mexico? Mexico has almost 2,500 municipalities in 32 states. So we needed a budget for each of them in terms of resources. Right? So we basically modeled, I'm going to explain how we answered these questions after this, but the second question that we wanted to ask is, what were the expectations, right? Like how many people will die, basically, which was a very gruesome question, and how many, but we basically also needed to answer this because it also takes resources, right? And also the RT, which is the transference factor for any disease. So for instance, if I have COVID, how many people will I transmit it to, right? If it's 1, then the pandemic will be flat. But it's more than 1, then it will grow. And if, in some cases, the RT in Mexico was like 15, 17, right? So for every person that was sick with COVID, they will spread it to 17 other people, and so on and so forth, right? So it was, fortunately, it didn't, right on time, the first confinement was implemented. So that basically stopped the transfer of COVID. But yeah, together with RT and other factors, we did all these projections and these calculations. And then the third one is we knew that, knew in the sense, we had a hunch that, of course, if you ask people to stay home, the spread of COVID was going to be stopped, right? But we actually wanted to measure it, right? And so we created a project to do that. I'm going to show you, which is the Unified Mobility Index by State. This was very, very interesting because it took data from Twitter, Facebook, and Google, and then based on GPS coordinates, we did a paired origin destination type of matrix, and created a baseline, because fortunately we had data from years, specifically for Twitter, so we were able to create a baseline, right? So people in, Mexico City moved this way before the pandemic, and then we compare the actual movement during the pandemic with that baseline. Right? And that was actually used by the Undersecretary of Health on a daily basis. He will say, okay, the state of Chihuahua has increased mobility and they should stay home, etc. Right? This was use to communicate with a lot of people. So yeah, I'm doing this talk because I think all these scientists that are amazing and they did the pro bono work should get some recognition. So yeah, I don't want to miss the opportunity to thank Mario, Oscar, Daniela, Eric, and Sabino for this. And they basically created this report twice a week during more than 2.5 years. Right? So it was a lot of work, and they actually had a lot of impact. But this was not it was very well communicated, but I think one of the other projects that also provided very interesting questions and answers was this vulnerability index by municipality, right? What we wanted to do is, okay, we know how many people are dying from COVID or are getting sick from COVID in each municipality, and we also have the census data, right? So we wanted to see which socio-demographical variables explained mortality, right? So we did a partial least square analysis, and we developed this index that basically was used to focus or to create a priority list on which municipalities required more attention, right? Just a quick insight on this, we found that the education level had like a very, very big explanatory coefficient for COVID deaths, right? And of course, we still need to, or back then, we still had to do more research onto why and to actually build the causal relationship. But to me, it was very, very interesting, and it made sense, right? Like, if the education level is very low, then people don't have access. They also don't have access to health services. They basically are abandoned by the government, right? Because when people don't have education level, it's not because they don't want to, it's because they don't have access to services. So to me, that was the explanation. And this was done by Raul, who I also want to thank. Then the third one, and I think one of the most impactful, was the estimation for the epidemic curves to determine risk, right? So basically this is the semaphore that the federal government used to say, okay, this is, for this state, they should be confined, right? Or this state has improved, so now people can go out and resume work. And what this chart shows, like the one on the left, is like we have the 32 states of Mexico on each row, and then dates. So you'll see, for instance, the top one, which is, it's not only the 32 states, it's also like regions. So the second from the top is the national median. So you'll see that on 2021, April 1st of 2021 until, I think it says, I cannot see what, it's basically 1.5 years, the time series, how it behaved on a national level, but also on each state. And when things went from yellow to orange, that's when the health ministry basically asked people to start staying home, right? And then, of course, the red ones are when the cases were super, super bad. And when we saw yellow to green, it was like a good sign, right? And people started to go out. But of course, when people start to go out, then the cases start to increase. So it became like one wave and two waves and three waves, and we have many, many different waves as we have, as we are showing on the chart on the right, which is the time series for Mexico City and how we calculated this, like the risk level. Like I said, this was used to determine if millions of people have or were able to resume work or go outside. So in my opinion, this was like super, super impactful. This was done in CMAT, which is the Math-Oriented Research Center, by technicians. They were not like, like these top scientists that are in CMAT and who also work on other projects. They were done by machine learning engineers that work with those scientists, and they created this very, very strict, like very, very fast. So thank you, Judith, Joaquin, Domingo, Yvette, and Juan Luis. And the last one that I want to show you, this was done also, like it was done in collaboration with CIMAT, the National University, and and other, I think it's UC Davis. So we, like from the beginning of the pandemic, we knew that we needed models, right, to basically say, okay, how COVID is going to hit on a municipality and metropolitan area level. So they created this fantastic, like the preprint is amazing. I love to read it. It's super, super interesting. It's a Bayesian model. Basically, you put every person in a box, right? So it's like people that are healthy, people that have been exposed to COVID, people that got COVID, people that got really sick with COVID and needed a visit to the hospital, then people that required ICU or a respirator, and then people who died, right? So based on that, and using these very sophisticated models, we were able to inform the government with like at least 3 weeks of anticipation, like where COVID was going to hit, right? And I remember one meeting that I was with, like the the top government officials in Mexico in Zoom. I was in my house. I'm not going to say on pajamas, but maybe I was. And they, like I was talking to the top army guy and the national security guy and all these like top officials. And they were asking these questions, right? Like, where do we need ICUs? Where do we need to move doctors? Where do we need, like, to put more resources? And yeah, I think this basically helped Mexico to deal with the pandemic a little better. I'm not going to say that we did it in a good way, because at the end of the day, like more than 400,000 people or 600,000 people, according to some sources, died in Mexico due to COVID. So, of course, like the ideal scenario will be for zero people to have died. But I think this model basically allowed the government to respond in a more efficient way, and that basically saved lives. And yeah, this was also one of the main, like, remember I told you that the promise I made to the researchers was that I was going to work as hard as I could to bring this information to the highest levels. The moment I told them that my work was done was when the president was on a live stream, and like he had printed this model, like we created a PDF that is actually open, this PDF, and he printed it, right? And he was like on a live stream, like in his desk, saying like, hey, I have this information from the Mexico scientists, right? And we are gonna make decisions based on this data. And yeah, so it was a Sunday. And in that moment, I told them, like, I'm done. But I was not done. Uh, so yeah, this predicted the wave, the first wave of COVID, which was very controversial, of course, right? Like, it was communicated to the public because when you have this amazing tool, it's also very tempting to communicate it widely and to say, hey, the pandemic is going to end in May 26th. I remember this date. Because that's going to be the peak, right? But of course, people on May 22nd was saying like, oh yeah, it's going to end, and they started going out. But we saw the first peak of deaths on May 26th, and then a small decrease. But then, because people started going out, they like a second wave, which was much more stronger, right? So, to me, this model, which was very powerful to make decisions like the ones I mentioned before, like the UCU, intensive care units and doctors and hospitals and whatever, it was very powerful to do that, but I don't think it should have been communicated, right? And it got covered all over the place, and it was like super, like the researchers, which are these guys that are fantastic, and I'm very proud to have worked with them, well, with all of them, but in particular with this team, because yeah, they have like, yeah, I'm very excited to talk about this. They got bombarded with media requests, so now I had to deal with the media too, because basically we asked them not to talk to the media, right? Like it's not convenient for the researchers to directly talk to the media, basically during an emergency, right? So I had to deal with that and control the situation. But yeah, I think it came with the territory. So yeah, just for the record, I want to thank Marcos, Antonio, Andres, and Maria Luisa for this fantastic and very impactful and very beautiful. Like I recommend you to go to the website, which is coronavirus.conacit.mx, and there you'll find like all these research products and PDFs and data. Like it was a very beautiful open data portal for this nasty. So just because I think I only have a minute, I want to talk a little bit about the impact. Well, I've already told you a little bit, right? But where is it? Oh, yeah, this is it. Like I said, critical decisions were made using the insights that we provided. One of the secondary effects of this research was that people were able to basically have levers to measure like health versus economic, or health versus economy, right? Because the confinement, even though it was the ultimate solution, it's not economically sustainable, right? Like people, especially in Mexico and other countries, live day to day, right? So if they cannot work, they cannot eat, right? So we had, or the government had to basically balance between that. And yeah, like I mentioned, Mexico's president presented one of our reports during a live stream and quoted it multiple times during his Mañanera, which is a daily press conference that he does. Then on a daily basis, we worked with the health ministry to, like, they also had a daily press conference, and before they went online, we had a meeting with them to see like the status quo, and yeah, basically, it was like a stand-up meeting, but with the Undersecretary of Health, which is Hugo Lopez-Gatell, who I also want to thank for the opportunity and the trust that he put in the team. And we did that for more than 18 months. So it took a lot of resources from our teams. And we also created many ad hoc analyses that were not actually published because they were like very specific. And yeah, mediatically, the data was covered by most of Mexico's newspapers, but also the New York Times did a piece on it, and many other media outlets. So I think it was a very impactful ecosistema nacional informático. And with that, this was supposed to say thank you, but thank you.
Thank you so much. We have time for a couple of Q&A, algunas preguntas y respuestas. Quien guste hacerlas, who wants to make one question, please raise your hand, and I'll lend you the microphone.
Hello, Raúl. Hello, Jocelyn. ¿Cómo estás? Me da gusto verte.
Hello. I'm so curious about your comments about how to best communicate model predictions to the public. And I think it's going to come up more and more. I would love to hear what you took away from that, about how to think about that version of public communication of science and risk when you're doing that kind of predictive modeling.
So, yeah, I mean, the main learnings I got from this is that, well, collaboration with them is key, right? And I think we need to actually make a really big effort to build bridges and to not only do the work, but also communicate it and to bring it to the right ears. And then also, for instance, if it's correct to do, like we can also communicate to the public, which is not very easy, right? Like if I go back to this, to the chart on the right, normal people think that the red line is the actual peak, right? But it's the median, and it's a probabilistic range. So we have the P10 and P90, right? And that's not very easy to understand or to translate into public policy, right? So I think the key, or the role, or the learning I take from this, and why I'm so proud of this work, because I became the translator, right? Like I was able to understand these guys, but also to collaborate with people that had no background on statistics, and so yeah, I think the main learning here is building bridges and liaison, how do you say? Yeah, so.
We have time for more questions. ¿Alguien más quiere hacer alguna pregunta? No?
Thanks for sharing all of this work with us. I was wondering if you had time to kind of go back and evaluate some of the models that you used to see if they were close to what happened in reality.
Unfortunately, we didn't did a postmortem, right? I think it should be done, right? And to see with the current data, like how will the models behave. We didn't have time to do it, but that doesn't mean that the models were not like tested, and actually all the these models need to pass all the hypothesis testing, like in a statistical way, to be statistically significant, right? So they were tested and soundproof, just to say, but they were not, we didn't do a retrospective.
Hola, Paola.
¿Cómo estás?
Fuera de ciencia de datos, no sé si sabes qué tan sólida se quedó el área en el CONACYT o la línea de trabajo de CONACYT para continuar, ojalá, teniendo este canal entre la investigación y la toma de decisiones en el futuro, si es que quedará en el poder la misma visión. ¿Se ha consolidado mucho o no sabemos?
Sí se consolidó. Well, I'm going to translate the question. Like, after this, what's the impact in CONACYT? Right? Like, if the area we created, and Celine helped create that, like we worked together for 2 years. One. If it is going to stay, right? Like, and the answer is yes. Like, we fought very, very hard to basically change the law so they will allow us to create this area formally. Right? So now they have like resources, they have plazas, which basically mean like positions, right, for directors and general directors and coordinators. And I think it's a medium-sized organization that took almost 3 years of my life to create. So yeah, it's going to stay, I suppose. I don't know if they, like after I left by the mid-2021. I don't know if, they released a couple of ecosistemas nacionales informáticos on other topics, but I don't think they did attack like the urgent issues or the pressing issues that we did. It's different, but sí respondí tu pregunta.
Bueno, agregando otra cosa a la consolidación, con lo último que me quedé sobre los datos de los 70s de la gente desaparecida, es de que habrían los documentos, la información, pero después decía el presidente que lo volvían a cerrar los documentos, ¿no? Entonces había como un estire y afloje entre los que querían accesar a la información y los que querían ocultarla. Entonces mi pregunta aquí, ¿en qué quedó eso? ¿Ya están totalmente accesibles a la gente que le interesa esta información?
No
Una.
sé si…
Y la otra, si ya está accesible a esa información, la gente que le interesa ya se acercó a… Porque yo lo que veo más difícil ahí es la captura de los datos. Y bueno, un trabajo similar lo hizo el Seguro Social. Y ellos tienen pues muchísima experiencia al respecto, ¿no? No sé si ustedes ya se hayan acercado a esa experiencia.
Bueno, respondiendo a la segunda pregunta, sorry, I'm not going to translate it, but basically it's about the disappeared people and how we, like, what's the results of that, right? And ¿está bien si sigo en inglés? Oh, okay. No sé si, o sea, la segunda pregunta es acerca de si nos hemos acercado a instituciones, ¿no? Y la colaboración para este ecosistema nacional informático tuvo a un gran aliado que es el Archivo General de la Nación, ¿no? Ellos son los que tienen más experiencia en la digitalización y en el manejo de estos grandes repositorios de imágenes y de texto. También respondiendo a la primera pregunta, what's the impact? I think the outcome of this was a database. I don't think it was publicly or it is publicly accessible. It's basically intended for use for researchers only. But there's a couple of papers published on this topic by the person from the Comisión Nacional de Búsqueda and people that were on my team, right? So they published that, and I think the database and the system really, really works and has helped find or give answers to these questions.
Thank you so much, Paola. Muchas gracias. Please give a warm applause to Paola.
Thank you. Thank you, thank you.
Muchas gracias. It's now time for the lunch. Hora de ir por el almuerzo. Quien guste está por acá. We are back in 1 hour, I think so, here, right? So, thank you so much.